Hello everyone, my name is Siyoung, and today I'll be talking about how to build modern applications with purpose-built AWS databases. We've got a lot to cover, so let's get started. We'll be talking about what's different about modern applications and their requirements. We'll also cover the various different data types, their use cases, and recommended services for each of them. And finally, we'll talk about why a purpose-built database made a lot of sense for our customers. So what is a modern application? Let's go back in history a little bit. Back in the 60s and 70s, the mainframe was a predominant way of building applications. This lasted all the way into the 80s when the client server was finally introduced, and it significantly changed the way applications were built. Apps started to become a little bit more distributed in nature, where a lot of the processing was now done on the server side. However, the underlying data model was still structured with the database underneath still being that monolith. Then the internet arrived in the 90s, and as a result, the popular three-tier application architecture emerged with a separate application server in the middle. Client and application code became more distributed, yet the underlying data model was still structured, and the database remained a monolith underneath. The thing I like to point out here is that if you think about it, for almost 3 decades, people typically built applications against a single database. And that's an interesting data point because if you've been in the industry for a while, you often bump into folks who would say, hey, I've been building apps for a long time and it's always against this one database. But what has changed? Fast forward to today, and microservice architectures are how applications are built in the cloud. Microservices are really good at a single task, and it allows applications to be, to build using smaller pieces. And that microservice has finally reached the database. We want to avoid a single overburdened database with one storage engine and one compute engine trying to handle all these different access patterns. These expectations have resulted in database management systems with specialized storage and compute layers that are optimized for given use cases and workloads. So this is so that a developer never has to trade off performance, functionality, and scale. Plus, what we've seen over the last few years is that more and more companies are hiring technical talent in-house to take advantage of the huge wave of technology innovation that the cloud is providing. All of this has led to highly distributed and loosely coupled application architectures that we see that are powering the most demanding workloads and applications in the cloud. Let's take a closer look at the characteristics of a modern app. There are a number of factors that are contributing to performance, scale, and availability of modern applications. First of all, users. The user growth is a common KPI for businesses, and the cloud's global reach enables businesses to touch millions of new customers instead of the hundreds that internal apps used to serve. The data volume. Businesses are capturing more data about their customers to either increase the value of existing products or sell new products. This results in terabytes or even petabytes of scales of data. And locality. Businesses are often expanding their presence into new markets globally to reach new users. But the performance, and businesses don't want to dilute their user experience in order to reach new markets. They still want to maintain that great performance. As our CEO, Jeff Bezos, often says, customers are always beautifully and wonderfully dissatisfied. So if customers find a better alternative, they'll use it. Request rates. Businesses use the cloud's global reach to develop more interactive user experiences in more markets. And they need their apps to handle this load without any performance degradation. And so if customers are playing an online game or watching a stock ticker or a leaderboard, that data needs to be correct in real time. Access and scale is also different. There are billions of smartphones in the world, and mobile is the bare minimum expectation today. Businesses are connecting cars, they're connecting manufacturing plants, and even devices in our homes. This means that many billions of devices are connected to the cloud. And economics, like businesses can't invest millions of dollars in hardware and licenses up front and hope they'll be successful. That model is not realistic anymore. Instead, a lot of companies are now and should hedge their success by only paying for the resources they use without capping on how much they can grow. These dynamics combined with the change the way business build applications in these modern applications have wildly different database requirements, which are more nuanced than simply running everything on a single relational database. In summary, seldom can one database fit the needs of multiple distinct use cases. The days of a one-size-fits-all monolithic database are behind us, and developers are now building highly distributed applications using many different types of purpose-built databases. Developers are doing what they do best. They're breaking complex applications and problems into smaller pieces and then picking the best tool to solve each problem. Instead of looking at a list of 100 different types of databases, what if we instead think about common database categories? This is a simple mental model to help us reason how builders use different systems. For example, on the far left, relational is a category. Many builders understand relational systems, so I won't spend a lot of time here. But if you have a workload where strong consistency matters, or where you work with a team that defines schemas, and you're not really sure of every single questions or what type of questions through ad hoc queries will be asked, but when you do, it matters that you always get back a consistent answer. In those cases, the relational is a good fit. This is where Amazon RDS and Aurora fits, that support both open source data engines like Postgres and MySQL and MariaDB, as well as commercial engines such as SQL Server and Oracle. However, to help with this change in how builders develop applications, over the years we've built a number of purpose-built non-relational databases. Starting in the key value category with Amazon DynamoDB, this is a database that optimizes running key value pairs at single-digit millisecond latency at very large scale. A DynamoDB table can have one item or a trillion items, and it will perform the same because it's based on a parallel or scale-out architecture. Many customers like Epic with Fortnite and Lyft use DynamoDB. And just to give you an example of the type of scale that DynamoDB supports, over the last 2 days in Prime Day, which is our biggest retail event for our company, DynamoDB requests from Alexa, Amazon.com, and the fulfillment centers total 7 trillion and peaking at more than 45 million requests per second. And that's only a fraction of the total capacity of DynamoDB handles on any given day. This is unusual scale. Next, in the document category, let's say that your developers want a flexible way to store and query data in a database by using the same document type data model that they use in your application code. Some refer to this as schema on read system. For example, take Intuit. Their automated compliance system ensures that all of the resources across thousands of different accounts meet Intuit's various compliance standards. The system tracks audit events from tens of thousands of assets that are each modeled on a JSON document. As Intuit built the system, they needed a database that can natively store, query, and index a diverse set of documents. And so for this type of use case is why we built Amazon DocumentDB, which is a fully managed MongoDB compatible document database. And it is purpose-built to help developers easily work with JSON documents in their natural format. But it's also architected to scale easily to meet customers' growing needs like Intuit. But let's say your application can't even stand single-digit millisecond latency. What if you need something faster? You need microsecond latency for things like a gaming leaderboard. You will need to use an in-memory database and have a cache that can access data in microseconds. And that's why we built Amazon ElastiCache, which is a managed Redis and managed Memcached system, and it's for customers like Grab and McDonald's and Peloton. And it enables them to retrieve data for real-time processing for use cases like messaging and real-time geospatial data for things like drive distance. Next, let's say you have a data set that is really large and have a lot of connectedness. Take Nike as an example. They built an app on top of AWS, which connects their athletes with their followers and provides personalized recommendations based on interests of more than 100 million users. That's a lot of connections. And if you think about all the athletes and all the followers and all the interests, it needs to process fast queries over all of that connectedness. For example, running a complex query to learn the top 5 interests of all the followers of a certain athlete, that is pretty easy to do on a graph database, but it's unwieldy slow on a relational one. That's why people are excited about graph databases, and it's the reason why we built Amazon Neptune, which is a purpose-built graph database for companies like NBC Universal, Netflix, and Uber for highly connected datasets. Driven by the rise of IoT devices and IoT systems and smart industry machines, time series data, and this is data that measures how things change over time, is one of the fastest growing data types. Time series data has specific characteristics, such as arriving in time order form. Data is usually append only, and queries are usually over a time interval. Time series data is not just a timestamp or a data type that you can use a relational database for. Instead, what makes it unique is that the single primary axis of the data model is time. This means you can highly optimize the data, how the data is stored and scaled and also retrieved. So for this, we built Amazon TimeStream, which is purpose-built for time series datasets. Next, ledgers are typically used to store a history of economic and financial activity in an organization. And many organizations build applications with ledger-like functionality because they want to maintain an accurate history of their application's data. For example, tracking the history of credits and debits in banking transactions, or verifying the data lineage of an insurance claim. For this, we built Amazon QLDB, which is short for Quantum Ledger Database, which is a fully managed ledger database that provides transparent, immutable, and cryptographically verifiable transaction logs. BMW uses QLDB for their digital vehicle passport application, and this maintains the complete and verifiable history of a vehicle, including maintenance records, tire changes, accidents, and all that stuff. This application will act as a single trusted authority where multiple third-party entities like car dealerships and repair shops can submit their data to BMW. And next, and last but not least, for applications that require high-speed data processing with single-digit millisecond latency, such as industrial equipment maintenance, trade monitoring, fleet management, and route optimization, a walled column database is a great choice. Apache Cassandra is a popular database for these use cases, and we've launched Amazon Keyspaces for Apache Cassandra, which is a scalable, highly available, and a managed Apache Cassandra compatible database service. Keyspaces is serverless, so you only pay for the resources you use, and the service scales up and down in response to application traffic. So you don't have to waste costs in over provisioning. You can also build applications that serve thousands of requests per second with virtually unlimited throughput and storage. When you think about this collection of purpose-built databases, you won't find this collection anywhere else. And when you have a company that says, oh, no, you don't need this many databases. I have a relational database and it can take care of all this for you. You should nod and say, And then some companies, and if some company says, no, I have a non-relational database and it does key value really well, and it does document really well, it does graph really well, it does time series really well, you should listen and be polite, but you should also be very skeptical. Swiss Army knives are hardly ever the best solution for anything other than the most simple task. And so if you want the right tool for the right job that gives you performance and productivity and customer experience, you want to choose the right purpose-built database for that job. And we're a very strong believer inside AWS that there is not one tool to rule the world, and that you should have the right tool for the right job that will help you save costs, be more productive, and provide a better experience for your customers. In summary, developers are building highly distributed and decoupled applications with microservices and cloud-based databases. But to make this real, let's take a look at some of our customers that are using multiple different types of databases for their applications. First, let's look at the Pokemon Company. They launched Pokemon Go, a very popular mobile gaming app. I think it was the kind of first that popularized augmented reality. But after a few years, due to the massive influx of the new Pokemon Go users, they ran into scale and management issues. So they decided to migrate to AWS instead of managing their own infrastructure. The team performed extensive testing to find a solution that met its security, scale, performance, and resilience. And they ultimately chose Amazon Aurora for their main database. The team also decided to move their user caching to Amazon Elasticache and took advantage of both Redis and Memcached. And finally, the team migrated the global configuration and time to live data to Amazon DynamoDB, which is a key value database that delivers single-digit millisecond performance at any scale. Taking advantage of the fully managed database services significantly reduced the overhead of managing all the nodes and all the clusters that they had to before. And so for things like the user session data and ticketing states, they were all stored in the cluster, and it sped up the Redis and Memcached clusters, so it sped up all the authentication processes and removed the need for a user to maintain a connection to a single server. In the end, less time managing databases meant more time for innovation. And so now the company is planning to use serverless computing with containers and microservices for even greater efficiency and performance. Airbnb, which is a popular app for renting vacation places around the world, they were challenged with scale and performance for their global app. And they now use DynamoDB to store user search history for quick lookups and personalized search. This provided them consistent performance even at internet scale. Airbnb also uses Elasticache to store session states in memory for faster site rendering that require microsecond latency with no lag or buffers whatsoever. And finally, they use MySQL on Amazon RDS as their primary database for transactional workloads, which is where relational databases are the most effective. Duolingo, one of the world's most popular way to learn language, I learned that they teach more language students than the entire US school system. They build their platform using DynamoDB as their primary database, and each second, Duolingo's DynamoDB implementation supports 24,000 reads and 3,000 writes per second. They are personalizing lessons for their 300 million users, which go through 7 billion exercises per month. DynamoDB also provides auto-scaling, which intelligently scales up and down the performance and capacity based on the user's needs. And this ensures high availability and minimizes any wasted cost due to over-provisioning. And Duolingo also uses Elasticache to provide instant access to common words and phrases. They also use Aurora for the transactional datasets, particularly for managing the user data. And finally, they use Redshift for all of their analytical workloads. Expedia migrated to AWS, and to an end user, Expedia, the website, may look like a single application, but behind the scenes, it is composed of many components, each with a specific function. By breaking down an application into multiple components that have specific jobs, using microservices and containers and Lambda functions, developers can be way more productive and increase scale and performance, and also reduce operations. When building an application, developers can then pair each use case with a database that best suits their need. And in the case of Expedia, Elasticache was used for real-time stream processing. Amazon Aurora was used for transactional data, and Redshift was used for all of the analytical queries. And also, and importantly, they used the AWS DMS, short for Data Migration Service, to simplify the migration process to AWS. As a result, Expedia is now able to handle more than 300 million updates per day at a rate of more than 20 writes per second. Capital One, which is one of the largest banks in the US, wanted to modernize their monolithic mainframe apps. They had, it was slower. It was large to manage. It was a lot of effort to manage that mainframe, and so they migrated to AWS databases. They used Amazon RDS to store transactional data for state management, and these are the best types of use cases for relational databases. They also use Amazon Redshift to store logs for analytics for those use cases that need aggregations as a data warehouse, which is best used for analytical use cases, and for the business analysts who need to slice and dice the data to see those insights. Finally, they use DynamoDB to store user data so that customers can quickly access their information within the Capital One mobile app. And they're utilizing the consistent performance that DynamoDB provides at any scale. And so we're seeing many financial customers like this who are moving their mainframe workloads to serverless or fully managed services like DynamoDB on AWS. These customers are able to focus on building faster applications with reduced latency, ultimately providing a better experience for customers. As you have seen in today's presentation, there are some common patterns of how databases are used depending on the workload. To help you get started today, we created a new learning page as a one-stop shop for all education content, which includes videos, tutorials, training courses on all of the purpose-built AWS databases. If you go to the page today, you'll see we provide in-depth tutorials on how to get started on each of the different database engines. We also have training courses based on use cases, like how do I migrate from my on-premise MySQL to a cloud version of MySQL in RDS or Aurora? How do I migrate from a commercial database like SQL Server Oracle to a serverless database like DynamoDB? Or how do I choose the right database for my new modern app that I'm building from scratch, but built in the cloud? We'll provide step-by-step guides on how to choose the right tool for the right job. And all of these courses are on the webpage, free for everyone to take. And when you're ready, we also have certification programs that help you guide your journey to learning. Speaking of certifications, we can also continue your learning beyond the summit with resources from AWS Training and Certification for databases. We recently launched new training courses on databases which includes multiple hours of deeper hands-on lessons, particularly on moving to managed databases, break free from legacy databases, and purpose-built databases. It goes in much deeper than the material we covered today, with hands-on and step-by-step guides on creating your first database, creating a new application, the different use cases, and walk you through some of the best practices of data modeling. Also, when you're ready, feel free to prepare and validate your experience with an industry-recognized certification for databases, all included with the preparation courses and the certification itself. So when you're ready, be sure to check that out as well. For more information, please visit aws.training/databases and look for the ramp-up guide that helps you create a series of learning courses to help on your learning journey. So with that, I'd like to thank you for your time. Please be sure to fill out the survey form to help us improve. And I hope you all have a good rest of the day. Goodbye.